official final exam review by topic area. And for those people who have not located this file yet, we were just going around the room a few minutes ago looking for it. I don't know if the website is working or not. I can give this to you for studying later. It's not working?
Working.
Oh, it's working. Maybe I need to refer. Oh, there it goes. It is located under the source code examples. What we're doing now is the very, very last one. It's called Objective-C Foundation Notes. It's going to be a review of the concepts you want to know for the final exam, actually, but I'm just going to go through it. So it's Foundation Notes. And then we're also going to take a look at View Lecture, View Controller 1, View Controller 2, and then the Example 1 and the Example 2. Goes through Model View Controller and some of the other things as well. Okay. So let's see what we're looking at here. It kind of starts out in the middle because I got rid of all the intermediate stuff and the beginning stuff that we already did a couple of times already in this class. But looking at the concept of properties. And this is kind of your final review, so take in consideration that you've seen all this stuff before. We're just going to summarize and conclude. I'll just kind of add some points on some of this stuff. So you'll have properties and synthesize on the exam. Properties themselves are explained here. So if I were to ask you, why do you want to use properties? What's the sense in all of that? Well, most importantly, it provides safety and subclassability for instance variables. Also provides values for lazy instantiation. What's lazy instantiation? It's kind of like the setters and the getters. So property and synthesize, the way that I've always explained it throughout the course is that it automatically creates those setters and getters for you. But technically it's lazy instantiation. It's making an instance of it, making it so it's accessible, and making it really just validates it as an instance variable for the most part. Also good for UI updating, consistency checking as well. So we have instance variables and we have class variables. Mentioned before, the concept of variables is on the exam. An instance variable, it's not required to have instance variables backed up with a property. Just skip synthesize if you wanted to. I use them in sets. And some properties might be calculated, usually read-only rather than stored. And it is possible to have instance variables without a property, but now we use property. So in the old days we had an option of doing property, or just doing property, or just creating variables. We can still just create variables. As you've seen in most of your assignments, you can actually create variables just by instantiating them and not use property to synthesize. If you do that, then you have to instantiate and you have to create your own functionality for it. So this is more of a way, that's why I keep calling it an automation way, but it really isn't automation, it's more of instantiation. Lazy instantiation is what it is. Synthesize makes it public, creates that instantiation for you, so you could leave out the synthesize if you wanted to. And if you did that, it would still be working just fine. It's not required. You can still declare the property using property and not instantiate it with the synthesize. But they do work in a team to complete both processes of it, if that makes any sense.
So the instance variable doesn't need a synthesize?
It doesn't, not normally.
But still you can go to the synthesize, that's what you're saying?
You can leave out, optionally skip out the synthesize. In the old days, Objective-C used to do it for you, and then it stopped doing it. Because people thought, oh, you just have to do it. It's just not going to provide the complete instantiation for you. So it's just going to make it, it'll still declare the variable. It just won't complete it in terms of the lazy instantiation and then the rest of it. Which, nothing more than creating setters and getters, for lack of a better way of describing it. So, why dot notation? Dot notation is kind of the pretty way of doing something. You can use dot notations. You can not use dot notations. We've seen them both. The dot notation is kind of the C style way of doing something. Objective-C has a different format. We don't use a dot notation one. Instead, we use an object name and then a message we're going to send to the object to call a method. We can also do the same thing with text, colon, to set the text of, let's say, a string or something, or the text of a property. Or we could also use another similar method. So we can't send messages to C structures, obviously, because they don't have methods. So when we send methods and run methods in Objective-C, we run them using the object name space the message. You can't use dot notation in that syntax. You can, however, use dot notation for structures that are supported and unions that are supported in Objective-C. It's really C style, however. As an example, here's a structure. So we have a dot notation here. So at property access looks like a C structure method actually, where we have a float X and a float Y, and then we have the name CG point. So noticing that we capitalize CG point just like the class names, if we're going to do this way, it makes a C structure more like an object. It isn't really an object though, it's a structure. So, and then you can use a dot notation with that as well. And here's an example of the kind of the syntax for it, just to refresh your memory on the syntax. We've defined the CG point here. This is actually defined for us in the language. We would not ever need to actually supply this code right here. It's actually, CG point is in the language already. And if we were to use that in an interface bomb, and we're going to put a, blast a bomb at a particular location, this is for a battleship kind of scenario, as is where this comes from. We've got at interface bomb, which is the name of the bomb class, or the class we're using. Property CG point position, CG point being the data type. And then we have our at end to end the interface. This is all put together, however it would be in two separate files, a .h and a .m. And then we have the at interface ship colon vehicle, where we get our inherents from. So ship is a vehicle. We have a property float width, a property float height, property CG point center, and then we have a method down here. There's a method here, and it's going to be a gets hit by bomb, and it's going to take a parameter. One parameter is going to be the data type bomb, and the parameter is going to be called bomb, and so returns whether the passed bomb would hit the receiving ship essentially. So this is the method prototype. This is the interface. We have two interfaces defined here. So it's just reviewing the syntax for you. So over here, what we're looking at then is that the property here, the implementation of it. So the implementation of it is on the right-hand side. This is the code we just looked at that's on the left-hand side. The left-hand side code is the .h file. This is the .m file on the right. So the at implementation ship, and then we would synthesize here the width, the height, and the center. And over here we know we have a property float width, property float height. This is the syntax for a property. Now, what's the difference between that and just float width? We could do a float width. So we can do a float width, float height, CG point center, and then we can create our own methods to get height, to get width, get center, set height, set width, set center. It's like what we do in Eclipse with Java. We just press it and it automatically creates it for us. Why bother with any of that stuff? Just put the word at property in front of it. And then over on the synthesize part, you could put it, actually you could put this all in one line if you wanted to. But here we have it all in one line. So notice here we left out all of the garbage collection stuff of the weak and the strong and everything. So if you look at an Objective-C project where you're creating an iOS or OS X and you're dragging, dropping components and you're sticking it over there and it creates a property for you automatically, it puts a bunch of stuff in there, which I was trying to tell you earlier. Don't worry about the stuff. Take the stuff out. The stuff's only for iOS. It's for garbage collection for the runtime environment that's being programmed for you. And you can set those options differently. However, technically you don't need it. Property works just fine like that. The synthesize works just fine like that. And for the purposes of the exam, leave it all out. A property space, the data type, the name of the data that you're using. Synthesize, the name of the data. So you don't have to repeat the type over here. You just put the data name in there. And here's our method implementation. And the method implementation is using the dot notation. So you know that we're setting properties. We can set properties with a dot. It's just like when we have a label and we go label dot text. equals something, or we set the property to equal something. We're using the dot notation for that. So the dot notation is not all that bad. It's just not used for running methods or accessing variables like setters and getters on properties, but it can be used with properties, no problem. So float left edge is going to be equal to self dot center dot x. Lots of dots going on there. So I didn't actually, you don't have to do this for the final, but just know that it is possible to use the dot notation in there, and it's still available. Now what do we have down here? Dot notation reference the object's at property. And it's the object's property that we're referencing with that. All right, so this next slide is just essentially going over the multiple dots that are in here as well. To reiterate that point. So going back to what I said before, when you drag an item over and you make a property out of it, let's say a label as an example, and you get this strong or you get this weak option that appears in there, as well as mnemonic or non-atomic, or I don't know what the other options are actually off the top of my head, but there's one more that fits in there as well. But long story short, it's going to tell you, tell the garbage collector to do something. So we also have nil and we have null in the language. Null means a reference doesn't reference anything. Null is like you get C++. The reference you created, unless a node or something, not pointing to anything meaningful, make it null. C++ doesn't have nil, however. Neither does Java. Objective-C has nil, N-I-L. Nil means garbage collect me. I'm done, I'm garbage. Because we have this automatic or well, it's actually more automatic than it used to be. Automatic garbage collector kind of concept that comes around and starts picking up objects when it needs memory. So the memory managers, refresh your memory on that concept. Memory manager sits around and looks for free memory cells. And if there are no free memory cells available, it needs to create one. If it needs to create one, it's going to look for something that's nil. And if it's nil, it's going to take that, dump it out of memory, and reuse it. Reuse that space for something else. So strong means keep this in the heap until I don't point to it anymore. Weak means keep this as long as someone else points to it strongly. If it doesn't, take it away. So weak is garbage collect me, and really strong is leave me around forever. So strong in the strong category, going back to this, keep this in the heap until I don't point to it anymore, which means until I tell you that it's no longer strong. So a piece of memory could essentially be out there forever because it's never going to be changed. It's always going to be, if you say something is strong, it lives around the life of the app or the life of the program because it can't be removed until I tell you it's going to be removed. I don't tell you it's going to be removed, it's not going to be removed. We don't have delete in the language. We use strong and we use weak to say delete or don't delete, but we're not explicitly saying just because it's weak that we're going to, you can delete me, which is interesting because C++, we just say delete, new, delete, and then that's how we manage our memory, and it's actually statically created. The whole scheme is static allocation, but it's done dynamically. In Objective-C, the entire language is dynamic. What I mean by that, and this is another concept for the final, is that it doesn't happen until it happens at runtime. It doesn't always happen the same way. If I have something that's weak, I don't need to have any memory. I'm not using enough memory to need it. May not necessarily go away. 5 more times I try the program, it might go away instantly. We don't know. So because it depends on what happens during the runtime. So going back to the strong, you don't want to point to it anymore. If it is set by my pointer, if I set the pointer to nil, I'm making it from strong, I'm making it weak. So strong stays strong until I set it to nil. So it's kind of like how we use delete. So in the code we can actually tell it to be nil. If it's nil, we turned it from strong to weak by our assignment. Or if I myself am removed from the heap because no one strongly points to me, no strong anything points to me, I get removed. I'm weak, I get removed. Whatever I'm pointing to also gets removed. Because in Objective-C, we don't have a deconstructor either. We don't even have a copy constructor, we don't need one. We don't even have a constructor if you think about it. Not built in, we have an initializer. So the concept of that strong basically is indicating kind of a manual way of just saying keep the memory there longer, and then I'll tell you when I want it to remove. By default, everything's weak in the language. Why is it weak? Because then the control of the system and the garbage collector can go by, and it can automatically clean things up for us. So we keep this as long as someone else isn't pointing to it strongly. If it gets thrown out of the heap, set my pointer to nil automatically. Now then over here it says if user is iOS 5 only. Around iOS 6 they took it out completely. You know, you don't have to say strong or weak, it just automatically manages itself. And in iOS 5 we used to have ARC as an option, automatic reference counting, where reference counting, let me talk about automatic reference counting as well. That's another concept you want to know for the final. The automatic is pretty clear. The reference counting is usually like, what do you mean by reference counter? This is a reference. So if I say, you know, integer I and I make I strong, I've got a 1. I've got something referencing it. If I make it weak and I'm not using I at all and I go away, it's now 0. So strong never gets strong is always counted. Weak is never counted. Doesn't count. It's a Boolean. It's either something's pointing to it or something's not pointing to it, which is actually kind of weird because a reference counter really isn't counting anything. It's a on or off flag that says garbage collect me or don't garbage collect me. So the reference counter goes from 0 or 1. If somebody is referencing, it's a 1. If nobody's referencing it, it's a 0. If no one's referencing it, it's a 0. It's weak, it gets garbage collected. If no one's referencing it, it's a 0. It's strong, it doesn't get garbage referenced. It just garbage collected. It just sits around forever, which is why a lot of people don't like to use the word strong on anything. And then they had a lot of issues with that. So then later on, around iOS 6, they took the option out completely and made it all automatic, made it all controlled by the environment. So it doesn't really matter really what you do with it anymore. I mean, long story short, now it's all automatic anyway. It used to be kind of semi-automatic. Now it's almost 100% automatic because it's just like Java. In Java, you can't tell it to collect something. Java, you can't tell it to keep something either. Well, you can sort of still do that in Objective-C, but it doesn't matter. The environment will clean itself up anyway. So this is not garbage collection. This is a way of working with memory to indicate whether or not it should be garbage collected. Garbage collection is a totally different concept. Garbage collection is just reclaiming memory. So strong, weak, nil, none of these concepts has anything to do with the concept of collecting garbage. It has to do with marking the memory for collection purposes. So garbage collection is just a way of removing stuff. So references are counted automatically for you. So find out you're about to leave the heap. Finding out what you are about to leave the heap. Well, that's dealloc. We don't have to use dealloc anymore. So we had alloc, and we still have alloc. Alloc allocates the memory. It's like new. So we use alloc instead of new. Retain makes it strong. Release makes it weak. So we used to have dealloc that made it weak. That said, okay, we're done using you. So there's a special method. It still actually works. You can do this, but it's not recommended right now. It's an automatic way of saying delete, essentially. Just like alloc is for new, dealloc is delete, essentially. But there's no questions on the final about that. You never have to do that, actually, because that's kind of antiquated. It's old. So it's old because it's senseless. It's kind of like auto release pool is not used anymore either. Auto release pool is when you just don't want to have to alloc and dealloc. We still have to alloc, which is kind of weird. But you don't want to have to go retain, and you don't want to have to go release, and you just want to allocate something. Then you create this thing called an allocation pool. Whole program just runs in it. You create the pool, you put everything inside of it, and then you drain the pool at the end. Well, when you drain a pool, it says just release it. So it's one big old retain and one big old release. That's what you're doing with all of the code in between. And then they got away with that. They said, no, we don't need that anymore either. So it's kind of weird. So. All right, moving right along. Here's our formal definition of nil. So the value of the object pointer that does not point to anything. And here's some syntax for you for ID as well. So if ID space object is equals to nil, and we know from the first couple of weekends in this course that ID is the generic object reference. There's a question about ID on the final exam, so you want to know what that is. You have to be able to write this. You'll have to be able to write something like this on this line of code here. So object could be anything. Anything can be of ID. ID is a type. ID is a generic type. It's kind of like the asterisk. It's the pointer type in C or C++. In C++. It's just an ID, a generic type in Objective-C. ID actually doesn't exist anywhere else. It's very Objective-C and Smalltalk actually featured. So here we have a valid line of code that sets an ID to nil, and then we have a NS string, hello string, which is also equal to nil as an example. So the value that doesn't point to anything is nil. Noticing that all objects in the language, just to review that concept, all objects in the language are pointers, whether we want them to be pointers or not. Everything's a pointer if it's an object. So NS stands for next step. It's the next step string. We have NS integer, NS float, NS double. What are those? Those are the NS parts of them, or the object versions of the primitives. So a float, a double, are primitive data types. NS float, NS double, NS integer are object of the same equivalence, except for it's been treated like an object. If you're going to treat it like an object, you're going to use an asterisk when you create the instance because it's a pointer object. And you're going to have methods that you can run on it. So you can assign it a value. You can't check to see if one float is equal to another float if they're objects, however. You have to run methods on them to compare them. It's kind of like what you get in C++ with that string. Create two string objects and you say, are they equal? They'll never be equal unless they're at the same memory address. But it really is not the same object. It is the same object, but it's, in fact, even sometimes that doesn't come out to be equal either. So you run methods on it to find out if it's equal. So you have is equal. You have different compare to, kind of like in Java, the compare to equals to test object identity and to see if something's equal. But in the most part, you're running methods on it. You're not treating it like a built-in primitive. So if you want to do that, treat it like a primitive. So we have the primitive types, integer, double, etc. Like 0 for primitive types. Well, actually, we do get automatic instantiation for primitives in Objective-C. Don't necessarily need to know this, but it's a nice little trivia bit. That, if you were to say integer I in C, or C++ actually, and then you see out I, it's going to tell you that I has been declared but not initialized. You're going to get an error message. Take the same line of code and switch it over to Objective-C and go integer I, and then do it like an NSLog or a printf on I or something. It'll work just fine. It'll come out and say 0. Because primitives in Objective-C are initialized to their default values. So a double will be a 0.0, float 0.0, string, empty string. Integers will be zeros. Most numbers start with 0. So it is initialized automatically for you. There's no separate declaration and initialization for it. Although you can instantiate it no problem. So all instance variables start out set to 0. Most people, I'm actually one of them that does it too. I'll just assign it to 0 because I do that in other languages and I don't want to forget to initialize it. But technically you don't have to initialize it. So the instance variables are pointers to objects. They start out with a value of nil. So if I created an NS string hello, this is actually kind of redundant. I could put the semicolon here, and so if I have the asterisk hello, it's already initialized to nil. So this is actually kind of unnecessary. This part here is really unnecessary because it is nil already, but which is actually kind of funny. So you can implicitly test it with if statements. So if object, curly brackets here to execute the object points to by the code, this will come out true. Whatever it executes will execute inside of here. If object means it exists, nil means the object doesn't exist. So if the object exists, and that's how you would test it for the existence if you wanted to. You don't have to worry about that. It's not on the final, but it's nice to know how to test for an existence. You can send messages to nil. It's mostly okay. No code gets executed. Nothing happens because the thing is nil. So if the method returns a value, it will return 0. So I have an object, it's initialized to nil, and I'm running a method on the object for some reason. And this one here is going to be a method which returns an int. And you're going to run it on the object, and you can sort of see the method call right here. What you've got is the object, ID object, you want to get real generic, and then object space, and then the message you're going to run on the object. This message is called method which returns an int. Doesn't really do anything, but long story short, because object is nil, it returns, well, what's it going to return? It's going to return 0, because that's the default value for an integer. So be careful if the method returns a C structure, because those values are undefined. Yeah?
Sending message to
Yeah, you've got an object, and the object is nil. You didn't instantiate it, but you made a reference to it. You made the object, but you didn't assign anything to it. Didn't instantiate, so it's pointing to nil. Kind of like this one up here. This guy up here is pointing to nil. And then you run a method on that object. And the method on the object isn't going to run, really, because the object doesn't exist. So if this method that's running on this object was supposed to return something, it doesn't return a real value. It just returns whatever the default value is for the primitive. This one is returning an int, so it would return back 0 as the default value. So you're taking and getting a default behavior on a default value. Why would you ever want to do that? I don't know. But sometimes you create an object and you don't instantiate it, and then you run a method on it accidentally, and you come back and you get 0 instead of errors.
So even though the method which returns an int returns some value,
it does return a value. It returns 0.
Since object is nil.
Yeah, because the object is nil. If the object is not nil, it'll return a meaningful value. Your question?
Same question.
Oh, did I answer it? Okay, good. It's no functionality really. It's just no error. It's just like, if I had an object, person P, and in C++, or not C++, C, but excuse me, C++, or even Java actually for that matter. If I said person P, but I didn't go person P is equal to new person, didn't create a new person for it to point to, I just created the reference, person P, kind of like here, ID object, and it's equal to nil, and I start running a method, I get an error message in Java. It comes back and says, or C++ actually, object not instantiated. Well, this object's not instantiated either, but this one just comes back because objects that are nil, objects that are created that are not instantiated are nil, just like, the same behavior if I didn't instantiate or different assign a value to I had integer I, and I say print I to the screen, it's going to come back and say I is declared, but it's not instantiated. There's no value. Same behavior. Objective-C just comes back and says, all right, you know what, 0. It will come back with something, it won't err out, is the point. So it's actually kind of nice that way. Because it's all dynamically allocated and dynamically assigned, it will actually run that way, which is interesting actually. So you can send messages to nil, you can return values that are not ever initialized. You can do a bunch of stuff without having to worry about it. So some consider it a little safer in terms of the expected behavior. Although you're not going to get meaningful behavior out of that. You're not going to get a meaningful result because what you're going to get is 0 or nil that comes back from something. Bool. That's just bool. Bool. Objective-C is Boolean type, actually just a type define. So it can be tested explicitly. If flag, if not flag. So yes means true, no means false. So no is equal to 0, yes is something else, but not 0. So it just checks for 0. If it's 0 or something else, then it's a Boolean. It's on or off. It's true or false. So. Instances versus class methods. This is on the exam, actually. And so what I've been trying to do is go over the stuff that is on the exam. Variable initializations, variable assignments, variable usage, default values for variables. So I covered the variable stuff. Now I'm into the class and the instance methods. Remember the pluses and the minuses? Pluses for class, minuses for instance. Here's the format. So we start out with a plus or a minus. This one over here is the instance. This one over here is the class. So we have a dash. I call it a minus. So they call it, this slide's calling it a dash. So instances start with a dash and pluses are the class methods. So class methods start with a plus sign. And we see the plus sign here, which is actually kind of funny because some people think this is a typo or something. They think it's like a bullet point or something. It's part of the code. If you haven't done your assignments, I would hope that no one is going to fall for this trick, or no one's not going to see this one at this point. But that minus sign is supposed to be there. Alright, so if you give me a code that doesn't have minus signs, then I'm going to be like, what in the world? I have no idea what you wrote here. It usually ends up in Microsoft Word files of some sort, or text files. But anyway, long story short, this one is for bomb, drop bomb. This is a drop bomb method. And this one's written over 3 different lines, but these are named parameters. It could have all been written on one line, actually. So the bomb is a class, and it lives in the heap, and we pass along the pointers to it. It's a point. We have a pointer here. This is a data type bomb. So CG points over here. It's a C structure and not a class. So it looks like a class name, but notice that there's no asterisk there because it's not an object. The reason why we're putting structures in this lecture example is because we want to tell the difference between a pointer and a non-pointer. Or an object and a non-object. So because the C structures are passed by value on the stack, it's not a reference to the heap. So there's no asterisk. So let's take this down a few notches here. And if it weren't CG point, it could be integer, float, double. In fact, underneath it we have, you can't see it, but there's the word double printed underneath it down here. Primitive data types don't have asterisks. Objects have asterisks. What do we got going on here? We got the, is it private? Excuse me, is it an instance or is it a class method? That's the first symbol. The second symbol is the data type in opening and closing brackets. So this method is going to return, and this is a method prototype because we have a semicolon at the end. This method is going to return a Boolean data type. The method name is called drop bomb. We use the colons in between each and every one of the parameters. The colons are separating the parameters just like commas would in C++. And these are named parameters. So we have bomb is the first one. At is the second one. From is the third parameter that this method is going to take when we run it. Over here on the right hand side, we've got some other class methods. Actually, we know they're class methods because of the plus sign in front of it. And this one's going to return ID, and it's going to be alloc. Well, that one's built in for us. So we would be overriding alloc, actually. Here's another one that's of data type ship with an asterisk, and it's called mothership. Doesn't take on, these do not take on parameters, by the way. Here's another one, and a string. Remember, we wrote the string, string with string, or we did something. We overrode this one. We actually wrote a method that looked very similar. Took on a string. Actually, we overloaded. We did protocol. No, we did a category. We added a method to the string class with that to do a string reversal, reverse string method. That was one of the exercises we did in the second weekend of this class. So here's string with format. Very common. String from integer, string with from format. Very common method. And then this is just ... saying it just includes a bunch of parameters. We're not going to worry about that. What we're looking at are the plus signs and the prototypes for class methods versus instance methods. Yeah.
So we say that the named parameters, right? There are only 2 named parameters, right?
We have the bomb, and then we have the at, and then we have from. All the parameters are separated by colons. This one doesn't have any, these guys don't have parameters. No colons. These guys have 1, 2, 3 parameters. There's 3 parameters over here, there's no parameters over here. If we had a colon, we're going to put a parameter in over here. Yes?
So what's the position? Position is a parameter.
Position,
GC point, and we are passing position.
position, yes. Oh, this is the data type. This is the name of the parameter.
Yeah. Add is it treating like a
Add is the, when you call it, and it's coming up actually, but when you make a method call, you'd say at colon and then the number,
Even we can
which would be a CG point.
Use this simplified. Add or from.
If you put at from, it just tells you with A, with B, with C, with D. It tells you which order and which parameter. They're called named parameters, and it's a name that you identify when you actually write the call to run the method. It's coming up actually. And you'll be running it with those names to specify, I want this one and this one and this one. So in one of the earlier lectures, we had one that said A and B and C or something. It's the same thing. The and A and B and C. More readable, yeah. You don't actually have to put this in here. You can take the ats out. You can take at and from out. You can just remove them and just put the colons in there and it works just fine. You put the words in here so you know it's at this one from here. Aim the bomb here from here, or at this point from here. So it's for readability, yeah, for the most part. Okay, so here we're going through starting with the dash, starting with the plus sign. It was just a little bit more information coming through. And normal instance methods calling syntax. We have the pointer to the instance and then we have the method. So here we have an example of ship. And we're running the drop bomb method. And this is going to be firecracker, which is a bomb. Because the first item we're going to give it is bomb. Actually, here's the illustration of running the method. So if we made a method call, created an object, and the object we're going to call is ship, and on ship we're going to run this method. The method we're going to call is drop bomb. Well, the first parameter is a bomb. There's no name for it, so we just say bomb. And then this could be on the next line with a space next to it, but it's separated for readability. At a drop point. The drop point's a CG point, and then from an altitude, which is going to be a double value. So this is how you would run the method, essentially. On the class end of it, just like C++, you run it from a class instead of from an instance. So this is run from an instance of an object ship here, and that's why we're putting ship in here. It's the object who's receiving the method. The message that we're going to send it, which is going to be drop bomb with firecracker at this drop point from here. So over here we have the creation utility method where we're going to call the syntax with a class and then a method. So we're using the class name just like you do in C++ actually. So if I have a ship is equal to ship mothership. So ship is the name of the class. And then mothership is the method mothership. This is this method here. And then string, result string, is going to be equal to, well, that's ns string, that's the class. Because up here we have ns string, which is the class. This is what the plus means. We run it on classes, class objects, not instances made of those class type. So we run it on the class type. So string with format. Well, this returns a string for us. And so the format's going to be this format for the result. And then ship class do something, which is the format that we're looking at. So this is the ship. This is a ship instance. the instance method called class returns the class of ship. And then this is the method do something, which is well, it's not on here, but let's say it's a class method. So this is an interesting trick you may not have seen yet, or may not even been aware of, but you can take an instance and get the class from the instance by doing it this way. Because it's really, if you have to run a class method, you want to run it from an instance, then you get the class from the instance and run it on that class. Hardly ever used, but it does come in handy when you have a class method. And you want to run it, and you only have an instance, so you get the instance class, which is really no need. You could just put the class in. You could just put ship in there, actually, and then run do something, whatever that method happens to be. So now we have self and super to think about. So this is a continuation of the previous slide. This is the same information that was on the previous slide with a last bullet point on the bottom here with the self and the super. So self and super is the calling instance, and self and super is also the class. So we get both concepts with both. Self means my implementation, if it's an instance, and super means my superclass's implementation. So self is me, like this is in Java. Self super in the class, from the class perspective, self means that this class's class method, or super, this class's superclass's class methods. So it means the same thing, used the same way with both the class and the instances. So methods. So now we've moved along to the method concept. Here's more examples of more methods. So we have double perform an operation, colon, and it takes on one string, and the string is going to be a NS string. So we have the data type in here, and the name of the, the method that we're going to, the parameter that we're going to use. This is kind of like saying, double perform operation string n, or string operation or something in C++. And then we have an NS mutable array object and no parameters there. This one's going to be operand stack. So it's just going to be one name of the method that we're going to use, but no parameters. So this is the method name. These are the parameters. Anything followed by a colon is a parameter list. We have string or do something, and just a bunch of methods in here. And then here's one down here. He's going to add a couple things together. So some instantiation examples. Asking other objects to create objects for you. And a string's a string. String by appending a string creates a string by appending two strings together, creates an object for you. It actually returns an NS string for you. NS mutable copy as an example. And NS strings plus an array, NS array. And let's see, components joined by strings. Not all objects handed out by other objects are newly created objects. Sometimes they're just the same object being returned. So here's the last object at index if you're looking in terms of an array. So if you do array manipulation, you return objects from the object by calling a method, such as this one here, object at index, which is very popular for that. Create an immutable array, or even an array itself, an NS array. And then you get the object at 1, object at 2, object at 3. Returns an object. So it's an object call that returns another object. So unless the method was the word copy, which it isn't actually in it, the object already exists. So you can get a pointer to it. And then you can use methods to create objects. So this is a string with format, a button with type, an array with capacity, array with objects. So methods are pretty handy. These are class methods, a string to create an object from an object method, class method. So these are instance methods. So we have another example here of allocating and initializing an object from scratch. These objects are created by running methods, instances, and class. We create objects from scratch by using alloc. Alloc is the object, it's a plus plus, it's a class method that returns an object of the type that we specify. So alloc and initializing an object from scratch. So that's why we're running init on here too. So this is another point you want to be familiar with for the final. So doing this is a two-step process. We allocate and then we initialize. So both steps must happen, one right after the other. We can nest them together. It doesn't really matter how you write it on the exam. You can write it in 2 steps, you can write it in 1, but you will be writing this. And you're running an initializer on an object. Well, that's if you choose to do it, I should say. So here's some examples of an NS mutable array, and it's going to be called stack, and it's going to be equal to an NS mutable array alloc init. And then here we have a calculator brain, and then it's going to be a calculator brain alloc. So we're creating an object of these different types and running the initializer on the objects and copying them into the variable references of the same data type. You can do this with an ID as well. So you can say ID asterisk stack is equal to NS mutable array alloc, because everything's an ID. So you can actually replace this reference type with ID for both of them, and it works just fine. Now you wouldn't put ID in here, ID alloc. What are you going to make? Generic data type? So that doesn't work. But you can reference this by a generic data type. So if you have a NS mutable array or a calculator brain or NS string alloc, anything you have in there can be an ID. It can all be assigned to an ID reference. So for allocating, the heap allocation of the new object is done. It's done by NS object. When you run init, init's coming from NS object unless you're creating a new initializer. So you can run an initializer without actually creating an initializer. It works just fine. So the class method, the plus ID alloc, is actually run. So it allocates enough space for the initialization and the creation. And these are the ones by using @synthesize. So @synthesize actually creates the initialization, the allocation for you. It does the automatic initialization. So the initialization, that's part with the init. So by the way, when you use synthesize, you don't use alloc and init. You don't need this for the final, but just to clarify a point. The reason why I use property is to declare the property. Synthesize does the alloc and the init for the property. So if I said property, NS string first name, and I synthesize it, I've allocated, I've initialized it. Without allocating and initializing it. It's doing it for me automatically. So synthesize is really allocating and initializing, and then setting the initialization sets the setters and the getters for you. So you can set the string, get the string. I have all those methods available for you. So you don't ever have to write a setter or a getter if you're using property and synthesize. If you don't synthesize but your property, you don't alloc and init, but you've done this. You've done a reference. That is created, but this part's not created. So you might want to think property is on the left-hand side, synthesize is on the right-hand side of this expression. I don't know if that's clear or not, but yeah. That's what it's really meaning, actually. So init, initialization, instantiation, more complicated init methods. What makes an initializer? An initializer is the word init in the method name. You can't write an initializer that doesn't have the acronym init or init in the name. So it's part of the name. So if an initialization method has arguments, it should start out with 4 letters. In init, example here, init with frame, init with string, init with number, init with something. Common syntax to use for that. So here's an example, init with frame with an initializer that takes on a CG rectangle. So it initializes it with a parameter. So here we have a UI view. My view is going to be equal to a UI view alloc, and then initialize with frame the perfect frame. Whatever happens to be that variable. So examples of multiple initializers with different arguments. So here's init with characters, init with format, init with data. Just different ways. You don't have. There's no law that says you have to name it this way. The only thing the law says is you have to put init in the name. So init's supposed to appear in there. But there's no rules that say you have to put it like, it has to be called that way, or you don't have to put the word with. The word with doesn't have to be in there. I mean, I could just say init using characters, init using format, init using data, if I wanted to. Okay, so classes must designate an initializer for subclasses. Just the same way as we created one in, well, if you've taken the C++ class, you can call back. Constructors from inherited classes can use constructors of previous classes, and you can specify which one to use. Similar kind of way. That's why in the init of a subclass, we call supers init. We initialize the super, which is our subclass, or our class above us, I should say. So the initializers of that subclass must be used the initializers themselves by designating the initializer. So that's the static typing of initializers for subclassing reasons. Init method must be typed to return ID, not statically typed, dynamically typed, because we don't know which one's going to run until runtime. So we return ID. So caller should statically type through my object is an object, and it's going to be equal to my object allocate and init. So an ID is not statically typed. ID is a dynamically typed, not statically typed. That's statically typed. So when you create your initialization method, here's an example of a review of how you create an initializer. You'll have to do this for the final exam. So this is why this lecture is kind of important, because you want to remember the syntax here. This will help you with the programming questions. So, not that I'm giving it to you, but I am. So here we go. Some people will still not pass it, though, which is interesting. Even I give you the answers to the questions I just gave you earlier. Here's an initializer. So create your own initializer. So it's sort of a odd-looking construct, but make sure it has a init in the name, initialize property. So the initializer can return nil if it's failed to initialize. Nil is an empty object, doesn't point to anything. So in that case, the subclass should also return nil. So this looks weird because it assigns a value to self, but it's the proper form. So you're assigning a value to self, which is the current object. So here's an example of what it would look like in the init, plain init, where the designator initializer is being used here. Implementation goes in the implementation, by the way. Does not go in the interface. It goes in an implementation. My object. And here we have init, the plain init initializer. So you can make init with something if you want. Self is going to be equal to super init. So call the super's designated initializer and return it to self. So self now is equal to the initialized super object. And then if it worked, if self, then this is where you're going to put your body of your code. And the code that you're going to put in here is the code that you're going to run for the subclass. And then return self. And then you return yourself, and then you're done. So this is what the initializer looks like. I'd memorize that. Or I would remember that. I don't know why. I'm not going to remember something without memorizing it. I don't know. Or if you know the concept, you can probably implement it quite well. Is this still working? Yes. Okay, good. I have to talk into my coffee cup. I'm noticing that the volume in the room is getting higher, so I'm talking more into my coffee cup now. Glad I have my coffee cup. Alright, some more information on the instantiation. This is the same slide as we saw before, but now it's applied to another example. It's the subclass of calculator brain with convenience initializer. So this one says init with valid operations. So this is another initializer that's created with a valid operation. And we're going to allow the list to be nil. And what we want is that we have an app property to be set for the array. So let's just take a look at the code here. We're always going to start out with a self is equal to self init. We didn't put the check in here, but we could. Return self, or not return self, return nil if, which is what, you know, up here, self is equal to super init. Well, if self, Otherwise, otherwise it's not going to, if self. Otherwise, it's just going to return self. Same code as before, but so, self dot validate options is equal to array. So we'll do something if we'll do nothing if self is equal to nil, because it doesn't work. This will fail. It will fail. So return self. So this equivalence of running an operation on a nil object, it will return nil. So remember what I said before, when we make an object, it doesn't get initialized. We don't initialize the object, but we run a method on the object. It comes back with nil, or came back with 0 if you're asking for it to return an integer value. You run a method, self.validate operations is equal to array. You run the method on the object of a nil object. It's going to return nil. So you don't even have to put this line of code up here to check to see if self came back. It's just another way of doing it, another example. Do it any way you think is more clear in terms of what you're looking at. The notes on the bottom, noting that you call your own designated initializer on self, not super. Running it on self, self.init. We're doing nothing to super with this example. And you might need to add something to designate what you want super to do. Again, so
Super.
you can still use super. It just left it out. Yeah, it's just another example. Just another. This was a little clearer. That's a little bit more creative. Just another way of doing it. There's more than one way of writing an initializer.
Again, not much difference between a convenience initializer and a non-initializer, right? Except for the name.
Correct. It's just the name.
Convenience.
A convenience initializer, I don't even like that word. I just like to call it a parameterized. You're going to make a parameter. You would create an initializer to set some variables or set some properties or something. So this is convenient because it's going to do it for you all in one shot instead of running methods on it after you create the object. It's like the use of a constructor in C++. Very similar. Dynamic binding. So dynamic binding, all the objects are allocated in the heap, and you always use a pointer. As an example here, and a string has an asterisk in front of it. Statically typed, yet it's dynamically run. So ID object is equal to S, not statically typed, but perfectly legal. Because ID is it is essentially generic, so it could mean anything. So never use ID asterisk. That would mean a pointer to a pointer of an object. That's like using a double pointer. Because ID is a pointer, it's just nameless. Because it's generic. So some people like to think, well, ID is just a pointer. So you just put a pointer there and you're not giving it a name. But you really are giving it a name because it's called ID. So the syntax looks kind of odd, but this is legal for that reason alone. Decisions about the code to run on a message seems to happen at runtime. Everything runs at runtime. There's no virtual in this language, which means we don't have to tell it which one to make. It dynamically allocates, dynamically binds, dynamically sets all method calls at runtime, which means it's definitely more flexible than a statically bound language. So not at compile time. None of the decisions is made at compile time. Everything is made at runtime. Static typing, for example, and a string versus ID versus everything else. So you can switch object types around, no problem. Purely innate in the compiler to help find bugs, to assist it with it. Neither the class or the retrieving object nor its superclass implements the method. It will crash. If the method's not found, and it can't resolve the location of an object in the hierarchy, the system just bombs out because it can't type check. It can't check for the object or the method statically because everything is run dynamically. So what does that mean? You got code that runs that just fails out completely. How many times has that happened in iOS development? Constantly. Yeah, you compile it and then you go to run it and it doesn't run. Half the time it's because there's a method, there's a mistake in there. It's not statically typed. It's not static. It can't be type checked. It's dynamic types cannot be type checked. So it's run checked. So runtime error comes back and spits out an exception for you. The exception might be that, yeah, it was a valid method. You ran it on a valid object, but it couldn't find it. It didn't know which method to run. It wasn't implemented, or it was missing, or there was a typo in the method, and it didn't figure out what to do with it. Those are the worst error messages to troubleshoot because the system just crashes. It's not going to tell you what line of code made the mistake. It's not going to tell you anything. In that case, what I normally do is go back and I check to see what's going on. Half the time, the problem could be found by caching, cleaning out the cache, cleaning up the project, because what ends up happening is you've got instances that are created dynamically and you have memory that's allocated, and the memory may not be cleaned up. Memory is not cleaned up. It might think it's out there, might be running the wrong one, and it will cause an exception over and over again. So there's actually a clean project, rebuild project kind of option in there. In that particular case, what you're doing is just refreshing the memory to get rid of something like that. So it's legal and sometimes even good code to cast a pointer, change an object from one type to another type. And in that case, here's an example of it. Remember the introspection object tutorial we did? In introspection, we had an outer window, an outer view, and inside the view, we stuck in there labels. Did that in this class, didn't we? Yeah, I can't remember. I have 3 sections of, well, 1 Android and 2 of iOS this term, so I'm like, what in the world? Yeah, we checked labels inside of labels and views and stuff. It's called introspection. You can go back and take a look at it. It was working with this concept where we figured out, well, what is this thing? If it's a label, or if this is a valid method that can run on this type of object, then do something with it. Because if we put a bunch of generic objects out there, don't create any properties for it. Just put the objects out there, and then we can look at the objects and see what they are. Try to run a method on the object instead of it just crashing on us. Because if we run the wrong method on the wrong object, it's going to crash on us. Although no legal issue. It's perfectly legal to run the wrong method on the wrong object, or the wrong method on the right object. It doesn't really matter. If it's the wrong method and it can't run the method, it's going to crash. Your source code is never going to tell you there's an error with it either. Can't find the error until runtime. Okay, so with that said and done, here's more on the introspection. Well, here's an example here where we have the ID object, and we have an NS string S, which is going to be equal to, well, let's cast object to an NS string. So that's an object cast. Dangerous. Best known what we are doing. Well, we better know what we're doing if we're going to do that. How do we know that object can be a string? Object might be something else, like a person or an employee or something. So it's kind of dangerous to cast, but that's legal. It's called to cast. You're casting one object type to another object type. So that's how you're going to get, well, for the most part, that's how you'll get the ships to work. Because then you'll cast it to a cruise ship, or you'll cast it to another type of ship. Or you'll just make ships out of it and use it as a ship instead of an ID or something. Now IDs are compatible. So here's our object type example for object typing. Our interface vehicle, and we have a method called move, and our interface ship, going back to that concept, just review this where we started originally, which inherits vehicle, and it has a method shoot. And then we have ship S is going to be equal to ship allocate initialize, and then S shoot. Run the method shoot on the ship. So now we have S move. Well, move is a vehicle. Move is a vehicle method. It's not a ship method. So no compiler warning. It's perfectly normal. Perfectly legal syntax since S is a vehicle. Normal object-oriented stuff goes on. No problem with that because vehicle is part of ship. Same thing we get in Java and also in C++. We can run methods from inherited classes. We can run the lower base class methods from the inherited classes. They call it upcasting. You can go up, but you can't go back down. well, you can't go back to, you can't start with a base class and run a derived class method because the method doesn't exist. But you can go from a derived class and run a base class method. The method does exist because every vehicle, every ship is a vehicle, but not every vehicle is a ship, if that makes any sense. That's casting, object casting. No compiler warning here, where we say vehicle V is equal to an S. No compiler warning, perfectly legal. S is a vehicle. So remember I said there's a question on the final exam about the is-a relationship and the object casting in instances. This is what I'm talking about. What can you do with the different object types that are all inherited together? Can you run a method from a base class? This is illustrating essentially the point of concepts. Here we have V shoot. V is a vehicle, and it equaled S. Well, S was a ship, but we took the S that was a ship, and ship used to have, and ship still has shoot in it, but we're referencing it as a vehicle. So now we get a compiler warning. When we go V space shoot, so it would not crash at runtime because it's valid actually, but only because we know that V is a ship. Compiler only knows that V is a vehicle. We get a warning, we don't get an error.
Still it compiles.
I'm sorry?
Still it compiles.
It will complain with a warning, but it still compiles just fine. That's when you start looking at those warnings. Because remember, a warning, it means something is unsafe. Sometimes it's okay if you know what you're doing. Other times it's really unsafe. It should be an error. That, some people would say should be an error, but it's really a warning. Because technically this does work. We allocated a ship. S got allocated a ship. We have all the ship methods. It's there. Just because we decided to reference it like a vehicle. So we took a large object, made it smaller. But technically we can still run that method, but we're not doing it. It's not kosher because it's risky. It's not safe. Because how do we know? If we just created a vehicle and we ran shoot on it, and the shoot was a ship, and we didn't create the ship first and then cast it to a vehicle, we'd get an error. If we did it the wrong way, I mean, if we didn't create a ship first. But because we created a ship, we can run it like a vehicle. So here's another train of thought. Follow me on this one. A lot of people, if you were looking at object of a person and then an employee and then a teacher, they'd create all teachers and then cast them back down to employees and people. Because you can go backwards, but you can't go up the other way. So if they thought one of these people was going to be a teacher, they'd have to cast it, reference, they'd have to do more work in the reference. But if you create them all as teachers and then downgrade them, if you accidentally run a teacher method, it'll come back with 0 because it won't be initialized. So it's a safer way of working with the hierarchy, which is kind of like what we do with objects in Objective-C when we start doing iOS and iPhone applications, actually. You create the highest level, but you don't use it. You got a view controller that does everything, but you don't use it. You're only using a little bit of it, a little piece of it. But if you wanted to, you can use the rest of it. You just have to assign it and cast it up to whatever it is you want it to be. Don't cast it, you don't do it, you don't use it. Does it take up more memory? Yeah, a little bit more memory. Is it safer? Yeah, a little safer. More flexibility, more functionality. It's just the same thing as creating a bunch of teachers when you're just going to use them as people. But you have it, just in case. And for that reason alone. It won't cast. You'll get a compiler warning. It'll come back with nil. It'll come back with 0. It comes back with the default behavior when an object was never initialized. Or it returns something that was never set because you didn't use it like a teacher, you used it like a person. But you allocated a teacher, you used it like a person, you left all that stuff empty, you went and you tried to run those methods. No message, no warning, no crash, nothing. You just get 0 or nil. Safer. So that's why you see people doing that a lot. So Also try to remember that this is the last weekend of this class, so I'm trying to give you the more advanced topics. Assuming that you have been studying and you know all these basic topics already. This is way and above the basic concept. This is your last weekend of this course. Okay, so more on object typing. What do we got here? We have ID object is equal to something. Object shoot. Well, that's an interesting issue. How do we know what the object is? It's ID. Alright, so the no compiler warning. The compiler knows that the method shoot exists. So it's not possible that object might respond to it. It might be a ship. Or what is shoot? A ship, yes. But we have not typed object enough for the compiler to be sure that it's wrong. So no warning. We don't know if it's wrong or not. In my opinion, that should actually be an error, but it's not. So it might crash at runtime if object is not a ship. So, or an object of another class that implements a shoot method. There's more than one shoot method, and there's ambiguity in terms of which one it is, which is more likely the problem. So when you have the logic messed up, you get these exceptions that occur. It's not, and sometimes the exception doesn't occur. It depends on what was assigned to that object and whether or not the object actually meets the right type for the right method that's being called on it. Lo and behold. Now we get a compiler warning when we say object, some method name that object anywhere responds to. Okay. Compiler has never heard of this method. Therefore, it's pretty sure the object will not respond to it. We're going to get a compiler warning. Most unresponsive method calls are not errors or just warnings. Like the method doesn't exist, or the object's the wrong type for that method. So we get warnings. Tons of warnings, no errors. We still haven't never gotten a compiler error. We can't type check, we can't error check objects that are dynamically allocated. We cannot do it statically. So you'll never get a static error message that comes out of a typing issue, which is ironic, but it's definitely hard to troubleshoot. That's why I say when you see those warnings, pay attention to the warnings. They're really errors. But we can't find the error until we actually run the program, which is why it's still a warning. If you don't want warnings. If you have warnings, explicitly cast this sucker. Get rid of the ambiguity or the likelihood that it might be wrong. Make it right. And then you can get rid of the errors, and get rid of the warnings. You'll never have an exception that occurs. But just because you have a warning doesn't mean you're going to get an exception if you're using it correctly. It's not safe. It's not guaranteed. Okay. Here's another compiler warning where we have hello shoot. And we're like, who's hello? Hello is a string. Does the string have a shoot method? No. Compiler knows that NSString object, knows that NSString objects do not respond to shoot. Guaranteed crash at runtime. It's a compiler warning. That should be an error. No compiler warning here. If we say that the a string hello is going to be equal to hello, remember the at directive? So this is minus a point on the final. If you leave out an at directive, it's kind of a big issue. Different. This is unique. For those people who just started paying attention, that's a unique symbol, that at directive. You got to put that in front of a string declaration. So if you left that out, or if you left out the asterisk here, that's like a point deduction. So the syntax is important. I'm not requiring you to memorize that much. Okay, so hello shoot. We don't know about that one. But then we have ship hello ship. That's going to be equal to a ship hello. Change hello into a ship. So we're casting hello to a ship. Hello's a string. No compiler warning, but we're casting. Compiler thinks we know what we're doing. This is really messed up. you can't cast a string to a ship. Yeah, it's not going to work out right. Definitely not going to work out right. But there's no warning or nothing. It works just fine. No problem at all, actually. It's perfectly legal syntax. It's just messed up. That's a logic error. That's just messed up. All right, so now we say, hello ship, shoot. Technically, we're right. No compiler warning. We're forced the compiler to think that NSString is a ship. It already does. So all's well. The compiler thinks guaranteed crash at runtime because you can't run shoot on hello ship because hello ship is a string that was casted to a ship. It doesn't include anything it's supposed to have for a ship. So the object cast isn't correct. It's like when you're in C or C++ and you take a double, you cast it into a string or something. Or you take something that's odd, like a string, hello world, and you cast it into a double. Or you take a float and you cast it to an integer value and you've lost half of the precision on it. It's just not very safe. So now this is interesting. We're going to take and make an ID here. We're going to cast the ID hello and run shoot on it. Well, what's hello? Hello is a string. No compiler warning. We force the compiler to ignore the object typing by casting in line. All's well. The compiler thinks guaranteed crash at runtime again because the compiler still thinks hello is thinks it's a ship. But now it's ID. We put ID in there. ID says it's anything it wants to be. So here's one of the necessary evils to talk about in terms of the ID. ID is good. It gives you flexibility, polymorphism, gives you really good dynamic behavior and dynamic typecasting. It's really bad because it doesn't mean anything for the most part. You can use it without understanding the meaning of something. So in this particular case, we're just making it compatible, although it's incompatible, by making it generic. So you don't want to make it a ship. You don't want to cast it to a ship, cast it to an ID. You're accomplishing the same thing. It's just generic. It doesn't have this method that you're going to run anyway. So this is an excellent time for a break, actually, because we've been going for about an hour. So I'm going to stop on this slide and pick this up in a few minutes. So I'm actually just going to pause this video, I think. I'll stop it. I'll break it up. So this is part 1. Next one's going to be part 2.